Hello everyone, welcome to the video. Today we are going to solve the problem minimum insertions required to make a string palindrome. In this problem, we are given a string as input and we are asked to return the minimum number of characters that we can insert in this string at any position such that this string becomes a palindrome. We have solved this problem in the past using top-down recursion and dynamic programming, as well as the bottom-up dynamic programming approach. You can find the link to those past videos in the description as well as in the top right corner of your video. In this video, we are going to solve this problem using the longest palindromic subsequence approach. So let's begin. Also, if you are new to this channel, please don't forget to subscribe and click the bell icon. Let's start. To begin with, let us first note the key things given in the question. We are given a string S and we have to find the minimum characters that we should insert in this string such that this string becomes a palindrome. So if we consider an example, if we have the string AB, we just need one more character. Why? Because ABA will become a palindrome. Similarly, if we consider another example, ABCD, then for this we need 3 characters to be inserted to make this a palindrome. So if we consider our solution as a black box, we are getting a string S as an input and we have to return an integer as an output. So what will our function signature look like? Our function signature will look something like this. Let's start thinking about this with the help of an example. Consider this string ABCAA. Now, to make any string a palindrome, this is just an example, but to make any string a palindrome, what can we do? We can simply reverse this string and add the reversed part to the original string. Now this has become a palindrome. But have we used the minimum insertions? No. Why? Because some characters of this string, if taken together, they already form a palindrome. So adding those characters here again was a bit unnecessary. So how can we optimize? Here I have extracted the 3 A's from the above string and written them separately because these 3 taken together already form a palindrome. So what is stopping this string from becoming a palindrome? This BC. So what can I do here to make this string a palindrome? I can just reverse the order of BC and also add it here. So this is the BC from the string, and since this was the middle of the palindrome AAA, we just had to add 2 new characters C and B here, and now this is a palindrome. So our answer now here is 2 characters. We can do the same with another set of characters. In the same string, even A, B and this A also form a palindrome. So we have written this here, extracted these out and written this here. Now what is stopping this string to become a palindrome? The 2 characters C and A are extra here. So we need to deal with them and make this string a palindrome. So we again just copy the remaining characters of original string, and as per this middle point of the palindrome ABA, we add 2 more characters as to the left as they were present in the right. The C and A were present in the right, so we added 2 new characters C and A. And now this has become a palindrome. So our answer is again 2. So what we can observe? We can observe that our answer, that is the minimum number of characters required to be inserted to form our string a palindrome. What will be that answer? Our answer will be n minus, n here is the length of the string, n minus whatever is the length of the longest palindromic subsequence present in that string. Example, here the length of the string was 5 and length of the longest palindromic subsequence, whether it is AAA or it is ABA, the length of the longest palindromic subsequence was 3. So our answer was 2. Now, what is our aim? If somebody can tell us how to calculate length of the longest palindromic subsequence, we have very easy way of solving this problem. We have solved this problem, length of longest palindromic subsequence, in our past videos. we have used multiple approaches, including top-down dynamic programming and bottom-up dynamic programming approach to solve this problem. You can find the link to those videos in the description as well as in the top right corner of your video. So this is how we can use the solution of the longest palindromic subsequence problem to derive the answer for our original problem, minimum insertions to form palindrome. This is it for this video. If this video was useful to you in any manner, please let us know by commenting below. Also, let us know in the comments what will be the next problems that you would want to see on this channel. Please don't forget to like and share the video and subscribe the channel. We will meet again in the next video with some other problem. Thanks for watching.